Welcome to Better's channel where we teach you basic foundation in physics and in mathematics. So today we'll be dealing with one simple part of mathematics that most students know we call surd. So today we'll be teaching you the first basic principle in surd. So how it works in terms of addition, subtraction, the multiplications and the algebra of surd itself. So for this part of this video we'll be starting with what we call the algebra of surd. So it says that most time whenever you are dealing with additions and subtraction in surd, it follows a particular principle which I state here that only similar surd can be added or subtract from each other in such a case, which means that whenever you are having a root, a separate root of something of this kind, a plus b, root b, this kind of root can never be added together. The best way to present this kind of root is to what? We write it out as root a plus root b. So from what we know earlier, so it said only similar surd can be added or subtract from each other. The only way these two things can be added or subtract from each other is when what you are having inside these roots are the same thing. They are similar or they are the same, or something of this kind. Adding root a plus root a. So this is the only case where you can add or subtract. So from here we are dealing with examples, other additions and subtractions also. So from here we say simplify the following. Question 1 says 5 root 2 plus root 2. The second example says B says 7 root 3 minus 3 root 3. And the third one says 5 root 3 minus root 3. But one thing you need to know first is that everything you need to know is that any root that is not having an outside number is having an invisible one from the principle. So from what we have here, solution 1. So we say A 5 root 2 plus root 2. So from what we have from this question here, it says 5 root 2 plus root 2. So solving this kind of question is very simple. By what? We are having the same roots here. From what we have here, we are having similar roots from both sides. The first thing that is advisable for you to what? After you are equals to sign, open a bracket. We are having 5 from this side, write it out. The sign that separates this from this is an addition sign, bring it out. And pick out the number at before this root here. It is true from this question there is no number here, but it is known to be what? Invisible one. So we bring it out as 1. So from these two roots you have here, pick one of it, you have it out as root 2. So 5 plus 1. Your final answer from here becomes 6 root 2. You can see solving this kind of question is very simple and straightforward. If only you will obey this principle, only similar surd can be added or subtract from each other. So we have our question 2. Question B to be given as 7 root 3 minus 3 root 3. So when you check this question, what we did here is the same thing that is going to repeat here. Check, we have 7 here before the root, we have 3 here before the root. Then click it, open a bracket, 7, the sign that separates these two roots from each other, minus 3. Close your roots. Then pick one of these roots, write it out, root 3. Then from here, your final answer becomes 7 minus 3 is 4. So your final answer from here becomes 4 root 3 for this question. So from what we have from the third one states that 5 root 3 minus root 3. So it always follows the same principle in addition and subtraction. So we have here as 5 root 3 minus root 3. So open a bracket from what we have here. 5 minus the invisible one. 5 minus the invisible one. Close your bracket. Between these two roots we have here, since they are similar, pick one of it again. Write it out as root 3. So subtract 5 minus 1. Your final answer from here becomes 4 root 3. So that is all concerning for this first segment of it. For the second part of it, we have the simplifications of surds, which says that simplify the following. But what you should always remember that this part of it falls under the use of what we call multiplications of surds. So from what we have here, we have our first question there under A that you have root 60. So what is expected of you solving this kind of question is that you have to look for a perfect, or you have to look for a product, another number in which you can use to replace this 60. It's your duty to know much about multiplication table before you can replace this 60. Now, from what we have here, let us come here. Let us first write out the product of 60. So from here we have 1 times 60, we have 2 times 12, 30, we give us 60. So from here we have 4 times 50 and any other product. So we can try to have 10, let's place it to 5. 5 times, let's say 12. Yes, 12. Will give us 60. So we have 10 times 6 will give us 60. So from all what we have here, we are trying to look for a perfect replacement for this 60 here. Check well. You cannot look for the square root of 1 at the same time square root of 16 straightforward. So what is expected of you is that all this product you have here as a replacement for this 60 you have here, you must be able to look for one of their square roots. When you check well, we cannot look for the square root of 2, likewise 30. We can't use it. For this, likewise, we can't use it. For the square root of, we can look for the square root of 4, and we cannot look for the square root of 15. So we can go with this. So one thing you must know is that for every number you are going to use to replace any given value inside this root, you must be able to look for one of their square roots. So from what we have here, we can say root 60 is the same thing as 4 times 15. So from what we have here, separate them, we see the same thing as having root 4 times root 15. Square root of 4 is what? Is 2. While for this 15, even if we look for a replacement for this, we can never get a perfect square root or a square of anything for this total down of this 15. We can read it as 15. So for me, our final answer for this question is still the same thing as 2 root 15. So for the B part of this question, we say that simplify with 80. So bring it here. Root 80. So we are going to look for a perfect replacement for this root 80, the same thing we did for this root 60. So we can say from here 1 times 80 will give you 80, 2 times 40 will give you 80, 3. So in order not to waste much of our time, we can just say for me 5 times 16 is going to give us 80. But one thing you must note is that every number you are going to use in replacing this 80, you must be able to look for one of their square roots, if not 2. From here, we can look for the square root of either of this. We can look for the square root of the 16. So we can say from here, root 80 is still the same thing as 16 times 5. From here, separate each of them in a separate root. So it becomes root 16 times root 5. Square root of 16 is what is 4. Why square root of 5 is not possible? Leave it that way. So 4 times 5, so it becomes 4 root 5 as our final answer for this question. Now, for the last part of it, we have the C. And the C says simplify root 32 minus root 98 plus 5 root 2. So we can say root 32 minus root 98 plus 5 root 2. So we look for a perfect replacement for this from here. It becomes 16 times 2. For this side becomes 49 times 2. Why for this? It remains itself. Why? We can't look for the square root of 2 directly from here. Then we can't look for the square root of 2 from here. So we can just say, separate each of these things in a separate bracket. So from here we can have it as root 16 times root 2 minus root 49 times root 2 plus 5 root 2. Okay, let me borrow a little space. Let me make use of the other side of it. Square root of 16 is 4 times root 2 minus square root of 49 is 7 times root 2. So, why for this other side of it, so we can leave it as the same thing as plus 5 root 2. Let these two things multiply themselves together. We have 4 times root 2 becomes 4 root 2. Why for this? Minus 7 root 2. Why for this? Bring it back plus 5 root 2. Since everything we are having here is having similar roots, so you can open a bracket, bring it out as 4 minus 7, 4 minus 7 plus 5. Close your bracket, pick one of these roots. We have 2. So when you add all these things together, first thing we do, 4 minus 7 give us minus 3. Minus 3 plus 5 give us our final answer as the same thing as 2 root 2. Rationalization of surds. So we have some examples of rationalizations of surds. We have a question of this kind: 3 all over root 2, 5 all over root 3, and others. Now in this case, I'm going to explain how rationalization of surds is being solved in a very easy way. So from what we have 2 methods to solve, and the 2 methods are being applied in the same way. So from the first question we have here, we say rationalize 3 root 2. So from this kind of questions, how is it solved? From the first method, we said, if what you are having as your denominator is having a root, use your denominator to multiply your numerator and itself. So it gives us something of this kind: root 3 all over root 2 times root 2 divided by root 2. So 3 times root 2 gives us 3 root 2. Now, from what you have here, you are having a root here, you are having a root here. Pick one of the root and write it out as 2 times 2, which is still the same thing as 3 root 2 all over 2 times 2 is what we have as what? 4. So from here, square root of 4 is what? Is 2. 3 root 2. This becomes your final answer for this question. Now, for the B part of this question, I only use the first method to solve this question. I'm going to make use of the second method. Now, we have question B as 5 all over root 3. For this second method, it says anything you have here inside this root as your denominator remains itself. Like the same thing that happens with this question in A part of it. You have to inside this acting as a denominator inside this root. So after multiplying everything, it still becomes 2. So from this part of it, we can say 5 times root 3 all over 2. So from this part, the final answer for here is what? 5 root 3 all over 2. If from what we have in this C part of this question, we have 1 plus 9 root 6 divided by root 3. These kind of questions are very, very technical. Don't forget, in this part of these questions, I'm going to be making use of this method 1, the way I saw this method 1, and it follows as use this denominator to multiply the numerator and itself again, so it becomes 1 plus 9 root 6 divided by root 3 times root 3 all over root 3. So from here, this root 3 multiplies everything here. So it becomes 1 times root 3 gives us root 3 plus 9 root 6 times root 3. Don't forget, a number having a root can only multiply a number having a root. So from here it becomes 9 root 6 times 3 all over root 3 times root 3. Pick one of the root out. 3 times 3. So from here we can have it as root 3 plus 9 root 18 all over 3 times 3 we have here as what? As 9. So for this part of this question, so we can say, since what we have here is 18, we can still break this 18 down. Look for a perfect replacement for it. So we are going to have that as root 3 plus 9, open a root again, put it as 9 times 2 for the perfect replacement for 18, and for this side, square root of 9 is what? Is 3. So from here, we separate what we have inside this root. So it becomes root 3 plus 9 times 3 times root 2. So all over what? 3. So from here, it becomes root 3 plus 9 times 3. It gives us 27, or we divide directly from here. 3 here 1, 3 in 3 becomes 1. So 9 times 1 gives us as 9 root 2 as our final answer for this question. Then when we said it multiplies, like the same way we said, it multiplies everything here. So it becomes root 2, let's say root 5 times root 2, which is the same thing as 5 times root 2, okay, plus 2 root 2 plus 2 root 2 times root 5 root 2, 2 root 2 times root 2 all over. Pick one of these from the first method, it becomes 2 times 2. So from here it becomes 2 times 2 is what we have as what? Root 10 plus root 2 times root 2. So it becomes, from here we have 2 root 4 all over root 4. So from here we have our next step as root 10 plus 2 times 2. For here we have here square root of 4 is what? Is 2. So our final answer for this question is given as 10 plus 4 all over 2. 2 here 1, 2 in 4, 2. So our final answer from here becomes root 10 plus 2. Conjugate surd has been one part of surd that has been very, very difficult for most students, but it's based on your knowledge of addition and subtraction. So from this time, conjugate surd has to do with if one side of it is addition, the other side must be subtraction. So when the other side is positive, the other side must be negative. So from what we have here, we said the first question, 2 plus root 5, close your bracket, open bracket, 2 minus root 5. When you observe what you have, check what you have here and here, they are the same thing. What makes them different from each other is this sign here, plus this side and the other side minus. Now, what it means is that everything you have inside this bracket is going to multiply everything inside this bracket. That is to say, we can present it as this. So we can present it as this, 2 open bracket, 2 minus root 5, close the bracket, y for this other side, plus root 5, open bracket, 2 minus root 5, close the bracket. So from here, 2 times 2 becomes 4, 2 times, okay, let's start first. This 2, since it's not carrying a minus sign, that means there's a plus sign here. plus times minus, plus times minus give us minus, 2 times root 5 give us 2 root 5. We are done with this part of it already. Plus times plus gives us plus, 5 times plus give us plus, root 5 times 2 give us 2 root 5, plus times minus give us minus, root 5 times root 5 give us root 25. We have here, we have 4. Minus 2 root 5 plus 2 root 5 is the same thing as 0. That means everything you have here, at most cases, are always 0. So from what you have here, we can bring in this. Root 25 is what we have as what? Minus 5. So from here, 4 minus 5, your final answer from here is what? Minus 1. So from here, what we need to get this type is just to check for the square root of 25, and we have this as 5. So for the B part of this, we have the same thing happens. What the same step we use in solving this question is the same step we apply in this question B. So from this question B, we have 5 root 2 plus 8. For the first bracket, for the second bracket, so it's going to be 5 root 2 minus 8. Close the bracket. So from here we solve. So we have 5 root 2, open bracket, 5 root 2 minus 8, close your bracket. That's to say everything you have here will multiply everything on this bracket. So we'll come on the other side, plus 8, open bracket, 5 root 2 minus 8, close your bracket. 5 times 5. Numbers without root will multiply numbers without root. Numbers with root will multiply numbers with root. 5 times 5. 5 times 5. Let me expand this. Root 2 times root 2 plus, okay, let me put the times back, times root 2 times root 2. We are done with this part. Now, root 5 root 2 times minus 8. So we can just say plus 5 root 2 times minus 8. While for this other side, we have it as plus 8 times 5 root 2 plus 8 times minus 8. So from here, 5 times 5, we have it as 25. Root 2 times root 2, we have it as what? Root 4. 5 times 8, we have it as minus 40 here times root 2. 8 times 5, we have it as plus 40 times root 2. Here, plus times minus is minus. 8 times 8, 64. So from what we have here, we can say we have here as 25 times square root of 4 is what we have as 2. Minus 40 times root 2 plus 40 times root 2. Everything you have here remains 0. So we can bring in what we have here as minus 64. So from what we have here, 25 times 2 gives us 50. 50 minus 64. So our final answer for what we have here is the same thing as minus 14 for this question. Now, for this C and the D part of this question is what we are going to look into from here. Remember that our numerator is having 5 and denominator is having 8 plus root 2. And for this, remember for this part of it, we're having a numerator of 5 and a denominator of 8 plus root 2. So from what we have, remember, use your numerator to multiply numerator and itself. So it becomes 5 all over 8 plus root 2. Remember, since you are multiplying with your denominator, the signs here will change to minus. So it becomes times, open bracket, 8 minus root 2, close the bracket, all over 8 minus root 2. So 5 times this will give us 5, open bracket, 8 minus root 2, close the bracket, While for this, it will give us 8 plus root 2, close the bracket for this, 8 minus root 2. But for this question, I'll be very straightforward with this. 5 times 8 is what we have as 40 minus 5 times root 2 is going to give us 5 root 2. Now, for this, 8 times 8, we have 64. If you use this to multiply this, use this to multiply this, they will both subtract themselves together. So let us go straight to the points. Root 2, okay, plus times minus gives us minus. Root 2 times root 2 gives us root 4. So from here we can say 40 minus 5 root 2 whole over square root of 4 is the same thing as 2, so it becomes 64 minus 2. Our final answer from here is what we have as 40 minus 5 root 2 whole over 62.